Hey, hi everyone. It has been a while. How are you? I hope all of you are safe and stay healthy now. Given the current situation, we are going to have online classes for the rest of the semester. I hope this outbreak will pass quickly and we can meet in the school again. And please note that after watching each lecture, you have to complete the quiz shown below this lecture on the course contents folder in the Blackboard to check your attendance. Students who finish both watching a lecture and a quiz will only be considered as attending the class. Excessive absence of the class will result in a fail in the class. Okay, let's get started. Today, we are going to talk about cloud computing. Do you remember what we covered last class? It's been a long time, so I think many of you guys already forgot what we did last time. Again, I'm going to ask some questions to remind you of what we learned last class. But I guess I cannot get answer from you now. We look at IS infrastructure. Do you remember what IS infrastructure includes? The components of IS infrastructure are hardware, system software, networking, data centers. Hardware, firstly, is the physical computer equipment such as desktop, laptop, keyboard, printer, mobile device, and other devices. Software is a program or a set of programs that tell hardware to perform certain tasks. Networking is sharing data or services, and we can say communication, computer communication. And the last component is data center. IS infrastructure is essential for companies regardless of industries. We talk about this uh, in the last class. Without a solid IS infrastructure, many businesses are left with unreliable support and business processes will be subject to interruption, delay, and failure. And we talk about organizations' challenges from managing traditional IS infrastructure. So today, we'll be talking about cloud computing and how it helps an organization address IS infrastructure related challenges. There are many definitions of cloud computing. So what is cloud computing? First, according to our textbook, cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configuration resource, such as network, server, storage, application, and services. And from the National Institute of Standards and Technology, shortened to NIST, cloud computing is the on-demand availability of computer system resources, especially data storage and computing power, without direct active management by the user. Cloud computing drastically changed the paradigm about IS infrastructure because by using cloud computing, users and companies don't have to manage physical servers themselves or run software application on their own machines. We can see many applications based on cloud computing. Gmail, Microsoft Office 365, and cloud storage provider like Dropbox or Google Drive, OneDrive are all implemented on top of the cloud computing. Then why cloud computing? The underlying concept is one of the resource allocation as required on demand. Once this can occur, then it can be solved using a utility-like process. Cloud computing helps to transform IS infrastructure cost from a capital expenditure to an operating expenditure. Organizations rent resources such as processing data and storing data or network from an external cloud service providers such as Amazon or Microsoft on an as needed basis and paying only for what is actually used. Then again, why we use cloud computing? Do you remember that I told you in the classroom that cloud computing is considered as a new solution to deal with the problems causing from managing IS infrastructure. So we'll talk about this in more detail later. Before talking about that, you need to know the unique characteristics of cloud computing. Then how these attributes of cloud computing can help us overcome the problems of managing IS infrastructure. First characteristic is on-demand self-service. Cloud consumers can access cloud resource in a buffet-style fashion on an as-needed basis without the need for lengthy negotiation with the service provider. In the case of Amazon Web Service, a customer needs only a credit card and can set up server instance or expand storage space via a web-based control panel. This characteristic allows business to have most flexibility. Second characteristic is resource pooling. It means that rather than renting out space or time to each customer on one specific, cloud providers manage multiple distributed resources that are dynamically assigned to multiple customers based on their needs. The customer generally has no control or information over the location of the provided resources. Third one is rapid elasticity. Typically, servers and other IS infrastructure, such as data centers, take several weeks or several months to be delivered and days or weeks to be configured, right? In contrast, in a cloud environment, computing resources can be scaled up or down almost instantly and often automatically. Thus, there is no need to purchase extensive equipment to prepare for an anticipated surge in demand. This characteristic is important. It's also called scalability. And fourth one is measured service. Cloud computing automatically analyzes the data needed and supports a metering capability at some level of services. We can monitor, control, and report the usage. It will provide transparency for the host as well as the customer. And last characteristic of the cloud computing is large, or we can say broad network access. The user can access the data of the cloud or upload the data to the cloud from anywhere just with the help of a device and an internet connection. These capabilities are available all over the network and accessed with the help of the internet. So with these unique characteristics, cloud computing can deal with the problems associated with managing traditional IS infrastructure. First, by using cloud computing, organizations do not need to update, maintain their current IS infrastructure, such as data centers, servers, or they don't need to purchase new IS infrastructure. Organizations just can access IS capabilities like using utility without installation and direct active management by the user. Second problem is about big data and rapidly increasing storage needs. Before cloud, organizations had to build new data center to afford the increasing and enormous data coming from SNS, e-commerce websites, blogs, or other sources. But cloud computing enables ubiquitous, convenient, on-demand network access to shared pool of configurable computing resources that can be rapidly provisioned and released with minimum effort or service provider interaction. With cloud, organization can access and adjust their data storage or servers on the cloud environment. It naturally resolves the demand fluctuation, which is third problem. And the last problem is the increasing energy needs. Energy consumption in IT services is increasing every year. The basic concept of cloud computing is sharing a pool of computing resources with others, like carpooling, to save gas and to reduce the amount of emissions. Cloud computing decrease energy needed in using of IT. And let's talk about cloud computing service model. Cloud resources can be sold in multiple ways. First service model is infrastructure as a service. It refers to cloud-based infrastructure resources that are delivered to organizations via virtualization technology that help organizations build and manage their servers, network, operating system, and data storage. Example services include Amazon Web Services and Microsoft Azure. PaaS stands for Platform as a Service. It refers to cloud-based platform services that delivers a framework for developers that they can build upon and use to create customized applications. Or servers, storage, and networking can be managed by the enterprise or third-party provider, while the developers can maintain management of the application. Final, Finally, the cloud may host pre-installed application to which user just buy access. This is the software as a service approach. We can call SaaS. SaaS utilize the internet to deliver applications which are managed by a third-party vendor to its user. Majority of SaaS applications run directly through your web browser, which means they do not require any downloads or installation on the client side. There are several popular examples of SaaS, such as Dropbox, Salesforce, Cisco WebEx, SAP Concur, and so on. From the table, you can see the different control levels for each cloud computing model. On-premise means without cloud, organizations have their own data center on-site. In this case, organizations have a full control over their data, server, application, everything on the data center. But in the other three cloud deployment models, cloud provider and consumer have differing degree of control over the computing resources in a cloud system. IaaS has more control over the computing resources compared to PaaS and SaaS. PaaS and SaaS does not have, especially SaaS does not have any control over their data, infra, and so on. And let's talk about cloud deployment models. We just talk about cloud service model. And now it is a cloud deployment model. There are 4 cloud computing deployment model that vary as per the requirement. But in this lecture, we only look at 2 types of cloud deployment model, which are public and private clouds. A private cloud is a cloud service that is not shared with any other organization. The private cloud users has the cloud to themselves. By contrast, a public cloud is a cloud service that shares computing services among different customers, even though each customer data and application running in the cloud remain hidden from other cloud customers. Companies can take advantages of many of benefits of a cloud infrastructure by creating a private cloud for internal use. This allows for rapid allocation of resources across internal needs without the complication or concerns of outsourcing critical function. In contrast, public clouds offer additional advantages such as scalability and reliability, but may raise concerns about security and compliance. There are many things to take into account when managing a cloud, whether public or private. Public clouds can present particular challenges because aspects of cloud management are outside the control of a business. When considering a public cloud service, the business needs to make sure that it will meet the business's needs, is a viable company, and is appropriately priced. Security is a particular concern of many companies. When we use cloud environment, we relied on third parties to make decisions about our data and platforms in ways never seen before in computing. It's critical to have appropriate mechanisms to prevent cloud providers from using customers' data in a way that hasn't been agreed upon. And from here, we'll be talking about advanced cloud application. The first one is service-oriented architecture, shortened to SOA. What the service mean by here is individual components of business processes. SOAs are hosted and deployed in the cloud environment, eliminating the need for an organization to reinvent the wheel. To achieve greater flexibility and agility, organizations have tried to move away from deploying large monolithic applications in favor of a service oriented architecture. By breaking down business processes into individual services, which you represented as green building blocks, organization can more swiftly react to changing business needs. And next, advanced cloud application is grid computing. We talked about last time in the classroom about supercomputer, right? Do you remember that? Supercomputers are used to solve the most computationally demanding problems, such as weather forecasting or scientific research. The supercomputer can perform more than 20,000 trillion calculations per second. But supercomputers are dedicated, integrated computers for solving complex problems. But even though it is very useful, it's very incredibly expensive. One alternative way is grid computing. Some problems can be decomposed into small sections, and these can be processed across the grid of many microcomputers, like your laptop or desktop, with the end result integrated back together. These grids can solve very demanding problems formerly solvable only by supercomputers and can be comprised of regular desktop PCs. These desktop computers can be configured to contribute to the grid when they have idle excess capacity, which is very often the case when users are performing simple tasks such as word processing. The last application is content delivery network. Large geographical distance leads to longer content transmission time. Content delivery network involves multiple servers at various locations. It means content delivery network store copies of content closer to the end user. The user's request is routed to the closest server. That is the reason why, regardless where we are, we can enjoy digital content using our devices on Netflix, Spotify, or other website seamlessly. Oh, it is not. It was not last. It is the last. Modern information system infrastructure are now servicing many of an organization's communication and telecommunication needs. Telephone service is being provided through voice over IP or VoIP, we call that, right? IS infrastructure are support email, instant messaging, and video conferencing using either desktop or dedicated installation. Skype is an example of VoIP. And green computing. Green computing has multiple drivers, both economic and cultural. And there are also multiple opportunity approach to implement green computing, ranging from increased efficiencies through cloud computing and server virtualization, where companies take many physical servers and combine them so they run on a single larger and more efficient server. Okay, everyone, we stop here, and next lecture we'll be talking about chapter 6, data management. And then please note that again, after watching each lecture, including this lecture, you have to complete the quiz shown below this lecture on the course contents folder in the Blackboard. okay? Otherwise, you lost your attendance and credit for participation. Students who finish both watching lecture and quiz will only be considered as attending the class. Okay, thank you for your thank you for watching this video, and then see you in next lecture.